Alright, week 5, day 2, still adding and subtracting some rational expressions. I kept it fairly simple when I did the day 1 lesson, meaning there was no factoring really that needed to be done. There was some multiplying and that kind of stuff, but no factoring. So that's where you're going to see some differences today. Okay, so we are still adding and subtracting rational expressions. Okay, and there is that first one, 1 divided by 3x squared plus x divided by 9x squared minus 12x. Alright, to be able to add, we have to have a common denominator. Now sometimes to be able to find that common denominator, you're going to have to factor one or both of the existing denominators. So, that first fraction, not much I can factor there, so I'm going to leave it as 1 over 3x squared. Okay. Second fraction, I have x divided by, now 9x squared minus 12x. How would I factor that? Well, do they have a GCF, greatest common factor, greatest place to start here. 9x squared and 12x, they do indeed have a 3x in common. And so then I have a 3x minus 4. Okay, some of you right now, and I say this because I've done this problem in the past, might be saying, hey, those x's, they eliminate each other. These two right there, gone. Okay, but I want you to hold on a second before you do that. Okay, don't do that yet because much like our first day, we need a common denominator to be able to add these. Okay, and I don't want you to take away something just to put it back. So if you see here, this right here is the quantity 3x squared. Okay, this right here is 3x and then 3x minus 4. Well, what's the difference right here between this 3x squared and this 3x? Well, the difference is that 3x needs an extra x. So it makes no sense to get rid of those x's just to put x squared back in there. Okay, so we're going to keep that x on that denominator and that numerator so that I can multiply by x. That x will make that denominator over here. This 3x and this x makes it so that now I have a 3x squared on my outside with a 3x minus 4. Alright, the numerator, I'll go ahead and multiply here on this one, is x squared. Okay, now on that first fraction, it had that quantity 3x squared, but it did not have this 3x minus 4. So I'm going to multiply by that 3x minus 4 on both the numerator and the denominator. So that second fraction has a 3x minus 4 being multiplied by 1. Okay, so this being multiplied by 1 right here, it just means I have a 3x minus 4. And then I'm going to write it so my denominators are the same. 3x squared times 3x minus 4. What you're going to find each time I do these is I will not multiply out my denominators, but I will my numerators because I need to be able to add or subtract them. Okay, so when I do this question, I am adding. Okay, so those numerators, 3x minus 4 plus the x squared, well, nothing's alike, so I'm going to actually put it so it's in standard form. Plus 3x minus 4. The denominator is 3x squared times 3x minus 4. The only reason we were able to add those is because they had that common denominator. I'm going to stop right here. What can x not be? Okay, well, with this 3x squared right here, x cannot equal 0. With this 3x minus 4, if I set that equal to 0, x will not be able to equal 4/3. Okay, when you solve that for x. Now, what we're going to do here is I'm going to check that denominator to numerators, or anything I can simplify. Remember, everything must be written as multiplication, meaning the denominator is already written as multiplication. So 3x squared times 3x minus 4. I cannot get rid of the x squareds right here and right here because the numerator is x squared plus 3x minus 4. That is not multiplication. But I am going to check the numerator and see, hey, is there anything I can simplify? So is there a greatest common factor on the numerator? No. Can I factor the numerator trinomial? Meaning, is there anything that multiplies to that negative 4 and adds to 3? And the answer there is yes. So I want you to factor that numerator. Alright, so I factored this numerator over here off to the side. Okay, so there it is in factored form, x minus 1 times x plus 4 divided by 3x squared times 3x minus 4. Alright, now this time nothing happens to simplify. This is my answer. Okay, I am going to make sure that since I did the work to write it in factored form, I'm going to leave it in factored form. Alright. Here is B. What I want you to do is I want you to, after you write it down, see if there's anything that you can simplify, meaning check out your 12 over 4. Can I do that? Hopefully you said no, because x minus 4 is not multiplication. Can I, x squared minus 8x plus 16, factor that? Probably, so that's what I want you to do. Alright, off to the side over there, I did factor that x squared minus 8x plus 16, so that now that first fraction is negative 15x divided by x minus 4 times x minus 4. Now you're welcome to write it as x minus 4 squared plus 12 divided by, and I'm going to write it like this for a second, just a single x minus 4. So when you look here, what's going to make these denominators common? Well, the one on the left has 2 x minus 4s, so the one on the right just has 1. Well, what does the one on the right need to be alike? Well, it needs another quantity x minus 4. Okay, so it needs that x minus 4 so that it can be the same. So the left fraction, we factored it, so that way we knew what the common denominator needed to be. So nice, I don't have to multiply that one by anything. Now on the right side, I multiplied by that extra x minus 4, so that now my denominator is the same. The numerator, I'm going to make sure I do distribute this. Okay, so that way I have 12x minus 48. Okay, I did that so that now when I add these two together, okay, so when I add, I can combine these like terms on that numerator. So that on the numerator, we have negative 3x minus 48. Denominator is x minus 4 times x minus 4. Okay, I'm going to stop here and say, hey, what can x not be? Well, x cannot be, I have an x minus 4 and x minus 4, so x cannot be 4. I'm also going to pause right here and say, hey, is there anything I can do to simplify? If I look at this numerator, I actually can factor out a negative 3. Okay, so that I have an x plus 16 over x minus 4, x minus 4. This right here, I've checked it, I factored it, but nothing simplifies. This is what I would expect as my answer right here. Negative 3 times x plus 16. I have factored the numerator. Okay, that's simplified up there. Big ideas. If you happen to try this answer and it didn't work, try plugging it in that way. Okay, sometimes they're a little bit pickier than what I am, but this one right here is what I would want as your answer. Okay. Next question here on this page. What I want you to do after you write it down, I'm going to move it here. After you write it down, I want you to factor any of those pieces that factor, and I will tell you 3 out of the 4 of them will factor. Alright, now that they are factored, okay, what I'm going to look is sometimes, not always, we learned on that first page that we did not want to simplify numerator to denominator because it wouldn't have mattered. I would have had to multiply it by the x squared anyways. This question, however, when you look at it, these 2's, would it make my question simpler just to simplify it? Well, when you look, the denominator on the left is x plus 4 all by itself. The denominator on the right, well, is it simpler if I just take out that x, just the 2? Yes, it is, because then I'm just left with that same x plus 4. Okay, now you're going to get mad at me because I made you factor the numerator out on the left, but once I get rid of those 2's because they are alike, I want to actually redistribute over here on the left, okay? So I'm redistributing right here because I need to be able to combine like terms, okay? I know it seemed really silly that I made you multiply them just to unmultiply them, or factor them just to unfactor them, okay? So now I had 2x plus 14 over here, and I have the x plus 4, and I'm going to subtract the x plus 10 over the x plus 4. So this time we simplified because it was helpful to simplify. Okay? Now, so when I'm subtracting something like this, something you need to be careful about is this minus sign is distributed to everything on that numerator. Okay, so I have a 2x minus an x, so that's x. I have a 14 minus a 10, so that's a 4. And my denominator's alike. Now, right here, what can x not be? X cannot be negative 4. Now, can I simplify more? Hopefully some of you saw that and go x plus 4 over x plus 4. Hey, my answer's 1. Okay? Those are gone. The answer simplifies to 1. Next example. Hey, I want you to write that down and I want you to factor anything that factors. Alright, so here we have the denominator of the first one is the only one that factored. Okay, difference of squares factors like I did on that denominator. So when I'm looking here, the left denominator has an x plus 5 and an x minus 5. The right denominator only has an x minus 5. So what does that tell me? That tells me that this one needs that quantity x plus 5. Okay, left fraction is going to stay the same. On this fraction, remember, I'm going to leave the denominator, don't multiply them out, no need to do so. But on your numerator, you are going to distribute these together. So go ahead and do that and see what you get. Okay, when you distribute that numerator on that second fraction, you do end up with what I have there once you combine your like terms. Okay, now remember this minus means I'm subtracting this whole thing. So make sure that that negative gets distributed. Okay, so that when you do this, I am going to start it off with a negative, so I'm going to come up here, a negative x squared, keeping it in standard form, okay? I have an x that I am subtracting a 4x, so I have a negative 3x, and I have a 3 that I'm subtracting this negative 5, so that it ends up actually as 8 over x minus 5, or plus 5, and x minus 5. Right here, what can x not be? X cannot equal 5. X cannot equal negative 5. Okay, both of them. I'm going to stop and see, is there anything I can simplify? Well, I can't get rid of any x's on the numerator denominator. Is there anything that multiplies to negative 8 and adds to negative 3? The answer is no. Okay, so this is my final answer. Okay. Last question, I want you to give it a try here, okay? So make sure you factor anything you can, and then get your common denominators. I'll pause and play throughout here so you can check your answer as you're going, and hopefully this time with no mistakes. Alright, there's what you should have when you factor anything that can factor. Now I want you to find out what you would need to multiply on each side to make them common denominators. Alright, there's what you would need to multiply by. Go ahead and multiply, and we'll check there. Alright, there's what you should have when you multiply the numerators. Okay, I want you to go ahead and subtract these two. Okay, there is what you should have when you subtract them. So now we're going to stop here and say, what can x not be? The last thing, I want you to see if you can simplify it. Can you factor the numerator? Can you simplify anything numerator to denominator? Alright, the answer to that should have been no. There it is in simplified form. Again, if you needed to hang out in tutoring Monday or Thursday during the week, then make sure you fill out the tutoring request form. Thanks.